Okay, so we're looking here at planes, or as they're also called, lamina, and we're looking for the dihedral angle between two planes when we're given the line of intersection. So we're just going to look here at our SolidWorks file. Now, when we look at our SolidWorks file, we have two planes here. We have a blue plane and a red plane, and they're sitting on, as you can see, the vertical plane and the horizontal plane are showing the different coordinates of it. Now, if I just hide the horizontal plane, the dihedral angle is the angle we see when we see our two planes meeting as two edge views. Our line of intersection, which is obviously the line which joins them, the line of intersection would become a point view. So we need to construct a line of intersection as a point in order to get our dihedral angle. So in order to do that, we're just going to come to our page here. So here we have our two planes drawn in an orthographic projection view. We have our elevation, we have our plan. Now if we look, the line BA and BA here, that is our line of intersection. So the first thing I'm going to do is just get a colour and I'm going to highlight the line of intersection. The use of colour in the questions is very good as it highlights what we're looking for. Now, neither of these lines is a horizontal line in my elevation or my plan. Therefore, neither of them are true lengths. In order to get them as a true length, I need to look in here perpendicularly to it to get an x1, y1 line, which is going to be parallel to my line AB. Now it's working out as a bit of a coincidence that they're nearly on the same line. That's okay. And this is my x1, y1. Now this view is after coming from a plan. Therefore this view has to be an auxiliary elevation. Because this view is an auxiliary elevation, we're going to take our heights from the elevation. Very important to label every single point in this topic, as it can get very confusing otherwise. Once we have all our dots, we're going to obviously join them together. So we have the plan A, B, C, D. And then we have the plan A, B, E. Now, as we were saying, AB is our line of intersection. So I'm going to put this in colour to highlight it on my page. Now, I need to get... because this line here is parallel to my x1, y1 line, I know that this line here now is a true length. TL for true length. I'm going to look into this line now in order to get my true length as a point view. So all my points are going to come up here now, parallel to my true length. And I'm going to get this line here now is going to be my x2, y2. This view is coming from an auxiliary elevation, so this has to be an auxiliary plan. Lovely. Now, I'm going to take my distances from my x1, y1 line back to my plan. As you can see, I don't have a great deal of space here, so I'm actually going to come in and I'm going to draw a datum line, which is going to allow me to maximize my space. I'm going to push the line AB on my datum line. So I'm going to take all my distances now from my datum line up just to ensure that it fits in my space. So as we said, AB is now going to be here on the ground. C will be here. E. Finally D. So I'm just going to extend on E. C and D. Now I'm going to join A to E. I now have an edge view of the plane ABE. An edge view is when a plane becomes a line. My line of intersection has now become a point, okay? And my plane ABDC has now also become an edge view. So my two surfaces now are two edge views. In order to get my dihedral angle, it's going to draw a little arc. Get my protractor. And I'm getting an angle of 57 degrees. And that's how we find a dihedral angle between two planes when we're given the line of intersection.